Welcome, travelers, to Adventures in Security. You felt it. Some sites just snap to life while others make you wait. Imagine if your browser could connect in a single round trip, shrug off flaky Wi-Fi, and keep a session alive while you walk out the door, and your phone switches networks. That's Quic, the transport under HTTP/3. It's not just a tweak to the old stack. It rethinks how handshakes, reliability, and security work on today's messy mobile internet. In this video, I'll show you why Quic feels fast, where the security gotchas lurk, and what to do so performance gains don't become blind spots. We'll cover what Quic is, how it collapses the old TCP plus TLS dance, and why that matters for latency and user experience. Then we'll dig into the less glamorous but more critical part: security. I'll explain the specific challenges Quic introduces for monitoring, DDoS posture, and governance, plus practical settings that teams can adopt on day one. Whether you're an engineer, a security analyst, or just curious why your phone streams better on the train, this guide gives you the mental model and a rollout checklist you can act on immediately. You can download a more detailed paper on which this video is based from the link in the video description. Quic UDP Internet Connections is a secure connection-oriented transport protocol that runs on top of UDP. Instead of stacking TCP for reliability and then layering TLS 1.3 for encryption, Quic builds security and reliability together. That lets it establish new connections in one round trip and resume previous sessions with 0 round trips when possible. Inside a single Quic connection, apps can open many independent streams. If one packet goes missing, only the affected stream waits. Everything else keeps flowing. Quic also supports connection migration using stable connection IDs, so a device can switch IPs or networks and continue the same encrypted session without starting over. Classic HTTPS often spends multiple round trips just negotiating before real content flows, and any packet loss can stall the entire connection due to head-of-line blocking. Quic cuts setup delay by fusing transport and cryptography, so encrypted application data arrives sooner. Its per-stream reliability means a hiccup retrieving one image doesn't freeze the rest of the page, improving perceived responsiveness. On mobile and last-mile links, where jitter and light loss are normal, this design shines. The net effect is less waiting on negotiation, smoother playback under mild loss, and lower tail latency for APIs, which translates into snappier pages and more resilient user experiences. Mobility breaks old assumptions. When you walk from a cafe to the street, your device's IP changes. In TCP land, that usually means the connection dies and must be rebuilt. Quic solves this with connection IDs, a stable identifier decoupled from the 5-tuple of IPs and ports. When paths change, say Wi-Fi to 5G, the client can prove continuity and the server can keep state without renegotiating from scratch. For users, this means fewer drops mid-video, fewer retries on form submissions, and less frustration during handoffs. For developers, it opens the door to smoother background syncs and lower abandonment during network transitions. Quic raises the security bar by mandating TLS 1.3 and encrypting most transport metadata, but that also reduces traditional wire visibility. IDS signatures that depend on TCP flags won't fire, and deep packet inspection becomes less informative. You'll want quick-aware telemetry like QQ log, richer server and application logs, and endpoint analytics flowing to your SIM. 0 RTT. RTT is round trip time. Resumption can enable replay of early data, so avoid using 0 ERTT for state-changing requests, or add freshness checks with a nonce and tight windows. Because Quic rides on UDP, configurations must guard against reflection and amplification. Enabling retry for unknown clients and enforcing per IP rate limits help. Connection IDs are powerful for load balancing, but can leak trackable patterns if you embed meaningful identifiers. Rotate CIDs on path changes and use privacy-safe encodings. Quic's stateful handshake can be abused for CPU or memory exhaustion, so consider stateless tokens, proof-of-work throttles in front doors, and auto-scaling with strict limits. Finally, modern proxies like Mask can tunnel arbitrary UDP over HTTP3, require authenticated, approved proxies, and block unknown quick egress so you don't inadvertently create ungoverned tunnels. The practical playbook looks like this. Enable HTTP3 but pair it with a quick-aware edge. Your load balancer, WF, and DDoS controls must understand UDP 443 and quick handshakes. Turn on retry for first-time clients to validate addresses and curb amplification. Define a zero RTT policy that forbids state-changing actions or enforces freshness checks before committing changes. Rotate connection IDs on path changes and avoid embedding user identifiers. Collect queue log, server access logs, and endpoint telemetry. Ship them to your SIM and build dashboards for handshake failure rates, zero RTT usage, migration frequency, and packet loss. Test under load, then stage rollout by cohort. That's it for this video. If you have questions or comments, post those in the video discussion. And until next time, be careful what you click.